Good evening, welcome to Videos Online Academy Tutorial. Thanks for watching our videos online. Please, if you are not yet subscribed to this YouTube channel, do well to press the subscribe button and the notification bell in order to see all of our videos online. Please remember to like the video, drop your comment, and remember to share with your friends and families at home. Thank you. God bless you. Amen. Now today I will be considering what? Circle geometry under the what? Under JAMB mathematics today. As we have talked about the what? The line geometry today, we are going to be considering what? Circle geometry. And when I'm talking about circle geometry, there are rules and regulations, there are theorems about what? Circle geometry. I would like to discuss those theorems before solving the what? The JAMB question before us. Remember to what? To stay with us till the end. Thank you and God bless you. Now, the first theorem, circle theorem geometry that we're having is what? Is that of what? The theorem about a chord. And the first theorem states that a line drawn from the center of a circle bisects the chord into two equal parts. A line drawn from the center of a circle bisects the chord equally. Now, what does that mean? Now, when I draw what? A circle like this, and I have the what? The middle of the circle like this, and from this middle of the circle, I have a chord here. A chord is any line that joins 2 points together on the circumference. This is the circumference of the circle, this is another circumference of the circle. And the line that joins these two circumferences together is what we call a chord. And the theorem number 1 says that a line drawn from the what? A line drawn from the center of the circle bisects the chord into two equal parts. Now, this is the center. Now, when I draw a line from the center of the circle, it will bisect this what chord into two equal parts. So if this is chord A and this is chord A, if this is chord AB, if this is chord AB, this line has bisected it into equal parts, and this is the middle point M. So meaning that A line AM is equal to line MB. So a line drawn from the center of the circle bisects the chord into two equal halves. That is theorem number 1 in circle what? Geometry. Theorem number 1. Theorem 1 in circle what? Geometry. That's it. So if you have to calculate any what? The length of a chord, all you just need to do is to join this line to form a radius with it. This is a radius. Because a line drawn from the center of the circle to any point of circumference is what we call what? Radius. This is radius. This you can also join this one to what? To form a radius R. So this is radius, and this is also radius R. They are what? They are equal. Now, we can use Pythagoras here, Pythagoras theorem, to solve problems under what? Under theorem number 1, which is all about theorem about chord. About chord. You can use cycle, you can use what? You can use Pythagoras theorem, you can use what? SOHCAHTOA, and this trigonometry what? Ratios. That's theorem number 1. Theorem number 1 said a line drawn from the center of the circle, this center of the circle O, draw a line drawn from the center of the circle O bisect the chord into two equal halves. That is theorem number 1. Theorem 2. Theorem 2 says that the angle at the center is twice the angle at the circumference. Okay, the angle at the center, as we have an angle at the center like this, and we also have angle at the circumference just like this. So here this is an angle at the center. Let me label this one Y, and this is angle at the circumference. Any point we are talking about center of the circle. Center of the circle is located in the middle, and we always call it what? Center O. And any other part apart from the center is called circumference. Now, the angle that falls on this part now is called angle, and it's angle on circumference. While this one is angle at center. So it has an angle at center is twice angle at circumference, meaning that Y is 2 times what? X. So angle at center is twice angle at what? Is twice the angle at circumference. I just abbreviate it. So angle at center is twice angle at circumference. So Y is equal to 2 what? X. Theorem number what? Theorem number 3. Theorem number 3 is angle in the same what? Segment. For example, now I have a circle like this, and I have a chord, and that chord Now this chord form a segment. This is a segment. This is a point we call segment. So a line, a portion bonded by a chord and arc. A side what? The portion here bonded by what? By a chord and arc. This is arc. You can call this one arc. You can call this what? Chord. So the area bonded by chord and arc is what we call what? Segment. Now, angle that comes from the same segment, you can see this angle comes from this what? Segment. And when angle comes from the same segment, this will be equal to what? This S will be equal to what? Y, because they are angle on the same what? Segment. So X is equal to Y. Angle in the same segment. Angles in the same segment are equal. Angles in the same segment are equal. So whenever we have the same segment, angles that comes from that what? From that same segment, they are all equal to one another. Another theorem that we ought to know is theorem what? Theorem 4, which is angle in a semicircle is 90 degrees. Angle in a semicircle is 90 degrees. How do I know that? So angle in a semicircle is 90 degrees. I'm just trying to summarize it. Now, angle in a semicircle. Now, for example, if I have a semicircle here, a semicircle, a diameter divides a circle into two equal halves, and that one half of the circle is called semicircle. This is a semicircle, this is a semicircle. And I say an angle in a semicircle, for example, now if I have an angle in a semicircle is 90 degrees. Angle in a semicircle, that is the angle here now, is 90 what? Degree, because this is semicircle, so the angle here will be 90 degrees. So angle in a semicircle is equal to what? Is equal to 90 what? Degree. So here now if I label this one O, A, B and what? C. Angle A, C, B. Remember the angle is located at the middle letter. So A, C, B. And just make sure that where your angle is located is at the middle. So angle C, B is equal to what? 90 degrees. Why? Angle in a semicircle. Angle in a semicircle is equal to what? 90 degrees. So we have theorem 5. Theorem 5. We are talking about theorem 5. We are talking about what? Cyclic what? Cyclic quadrilateral. Angle in a what? In a cyclic what? Quadrilateral. Now, I'm talking about cyclic quadrilateral. For example, now, for instance, now, I'm talking about cyclic quadrilateral. What do you mean by cyclic quadrilateral? Quadrilateral itself is a four-sided polygon. That is a shape that is what? A plane figure that is bounded by four sides and four angles. Now, when I'm talking about cyclic quadrilateral, it's a quadrilateral inscribed in what? In a circle. Now, so a cyclic quadrilateral is made up of what? A quadrilateral that is being inscribed in a circle. So like that. Now, this is a quadrilateral that is being inscribed in a what? In a circle. Now, so when you have quadrilateral now, and these vertices of this quadrilateral is touching what? These vertices of this quadrilateral is touching the circumference of the circle. Then the theorem says that the opposite interior angle of a cyclic quadrilateral are supplementary. The opposite interior angle of a cyclic quadrilateral are supplementary. What do I mean by that? X angle X plus angle Y is equal to what? 180 degrees, and angle A plus angle B is equal to what? 180. That theorem under cyclic quadrilateral, we have another theorem under cyclic quadrilateral. Now, and that theorem is all about this. Now when you have something like this, four of us ensure that the vertices touch the what? All the four vertices touch the what? The circumference of the circle. So when you have something like this, and this, so the exterior angle, look at this, the exterior angle of a cyclic quadrilateral, this is the exterior angle. This is the interior angle, and this is the exterior angle the exterior angle of a cyclic quadrilateral here. If I draw this one out now, the exterior angle of a cyclic quadrilateral is equal to the what? Interior angle. Like the exterior here is equal to this. So if this is x, this also will be what? X. The exterior angle of a cyclic quadrilateral is equal to the opposite interior angle of that what? Quadrilateral. Now look at this. X is equal to what? Y. Angle x is equal to y. And angle A here is equal to angle what? B. That is the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle of that one, cyclic quadrilateral. So A is equal to B and X here is equal to what? Y. And the last one is what? Is based on what? On tangent of a circle. Another theorem that we have here, which is theorem 6, is theorem about tangent. I'm talking about tangent. Tangent is a line that touch the outside part of a circle. Now, when you have a straight line, when you see a circle meeting a straight line outside, you call this one tangent. And what? And the radius of a circle is perpendicular to what? To the tangent of a what? The radius of a circle is perpendicular to what? To the tangent. So whenever a radius is drawn from the center of a circle, it's what? It is perpendicular to the tangent. You call this one tangent. You can call this one T. You can call this one A. So this is tangent what? ATB. So this is line. The line. This is a line. It's a straight line which touch the circle at tangent T. So that is what? So this radius R. This is a radius R. Make an angle of 90 degrees with what? With what? With the tangent line. So this is one of the rules in what? In circle geometry, that is the radius of a circle makes an angle of 90 degrees with the tangent. So that's one of the what? Theorem. And the last theorem here is angle in what? In alternate segments. Angles in alternate what? In alternate angles in alternate segments. Angles in alternate segments. When you have something like this, angle in alternate segments. When you have something like this, and this form, this is a tangent here. So the angle here is alternate to this, is equal to this, and the angle here, we call it angle in alternate what? Segment. The angle here is alternate to this, and the angle here is alternate to here. We call it angle in alternate segment. They are equal, and these are theorem that is specific to what? To tangent. So let's quickly go to the what? To the JAMB question before us and answer the questions that we are being what? Given. The question before us says that a chord of a circle of radius 7 cm. So the question number 1, R is equal to what? 7 cm, and the distance of a chord of a circle of radius 7 cm is 5 cm from the center of the circle. Now, if I have a circle like this, here is a circle. Now, we are told that the circle has a radius of what? You can just draw it like this, a radius of 7 what? Centimeter. So, and the distance of the chord from the center of the circle is 5 centimeters. So, assuming I'm having the chord what? AB here, chord AB here. The distance of that what? Of that chord from the center now. So, the distance of this chord from the center is what? 5 centimeters. So, the distance of this chord from the center is 5 centimeters. What is the length of the chord? You have to calculate the length of chord what? AB. Now, you know that the line drawn from center of circle bisect the chord into two equal halves. So this place will be what? Will be M. So that's the first theorem. The first theorem said the line drawn from center of circle bisect the chord into equal halves. So this will be the middle point. So to calculate the chord now, length of the chord AB will be equal to 2 multiplied by AM, line AM. The length of the chord AB is equal to 2 times length AB. Now, so to get chord AB, we need to get AM, line AM. So, to get line AM, now we bring out the triangle here. Enable this one up. Consider triangle AOL. So we have what? Right angle triangle 5 cm. This radius 7 cm, and we are looking for what? AM, which is what? Line AM now, let's represent it as what? X. So using Pythagoras what? Using Pythagoras rule or theorem. So we have hypotenuse square equal to opposite square plus adjacent what? Square. So we have 7 square equal to what? The opposite is 5 square plus s square. So this is 49 equal to 25 plus what? X square. So s square is equal to 49 minus 25. So s square here is equal to 1 minus this one is 4. This one is 4. 9 minus 5 is 4. 4 minus 2 is what? 20 what? 4. So taking the square root of both sides, x is equal to now. You can write this one in what? In short form. This is 4 times what? 6. And the square root of 4 here is 2. So s is equal to 2 root what? 6. So s is 2 root 6 centimeter. Now we have successfully get what? Line AM. Line AM is equal to what? Line AM is equal to 2 root 6. 2 root 6 centimeter. So line AB now will now be 2 times 2 root what? 6. Because we say that line is 2 times AM. So 2 times what? 2 is what? We have what? 4 root what? 6. So the answer here is 4 root 6 centimeter. 4 root what? 6 centimeter. 4 root 6 centimeter. So the answer here is 4 root 6 centimeter. We have the option here. 4 root 6 centimeter option what? A. Question number 2. Question number what? 2. The question number 2 here. When you look at this word, the circle geometry here very well, you can see that this is a semicircle. This is a semicircle. And whenever we have a semicircle in a circle geometry, whenever you have a semicircle, the angle here will be equal to what? 90 degrees. So this angle here is 90 degrees. So I want to say angle what? Now I have to angle PQR. Angle PQR equal to 90 degrees. What? Angle in a semi what? In a semi circle is 90 degrees. Angle in a semicircle is what? 90 degrees. So angle in a semicircle is 90 degrees. So angle what? PQR is 90 degrees. So you can easily get our x now. You can easily get our x. Now angle x plus 90 degrees plus this angle here will give us what? It's a tell us what? If angle QPR is 90 degrees, find angle what? QRP. Angle QRP. You have to calculate angle QRP. How do you calculate angle QRP? Now angle QRP, which is this angle? This is angle QRP. Angle QRP plus angle X plus 90 degrees will give us what? 180 degrees. Sum of angle in a triangle. So we need that X degree X plus 90 degrees plus what? Angle QRP is equal to what? 180 degrees. Why? Sum of angles in a triangle. Sum of angles in a triangle. Sum of angles in a triangle. So now we have X plus 90 plus what? Angle QRP. So angle QRP equals 180 degrees. You transfer this X and 90 degrees to the other side. So minus 90 degrees minus X. So what do we have now? 180 degrees minus 90 degrees. When you transfer 90 degrees it will become minus x, when transfer x will become minus x. So that's why you have 180 minus 90 degree minus x. So now 180 minus 90 degrees is what? 90 degree minus x. So final answer is 90 degree minus x. And the option is option what? B. Option says that question mark says that in the diagram above, PQR is a diameter. POQ is a diameter. You can see here POQ is a diameter. Now, what is it again? POQ is a diameter of the circle PQR. If the PSR, now look at this, we say PSR, angle PSR, if angle PSR, meaning that we are going to connect this line together. Angle PSR is what? If angle PSR is 145, so this angle here is 145 degrees. Find the x, angle x, find angle what? X. We are asked to find angle x. How do we now get angle x? Look at this very well. This is triangle PSQ. Triangle PSQ form a semicircle. Triangle PSQ is a triangle. We have triangle PSQ here, and it is closed here by what? A semicircle. So angle here, angle PSQ here will be 45, will be 90 degrees. Angle PSQ here will be 90 what degree? This one is 90 degrees. In what? In triangle what? PSQ. In triangle PSQ. Angle PSQ is equal to what? 90 degrees. Why? Angle in a circle. Angle in a semicircle. Angle in a semicircle is equal to what? 90 degrees. Is what? 90 what? Angle in a semicircle is 90 degrees. So angle in a semicircle is 90 degrees. So angle PSQ is what? Angle PSQ is 90 degrees, as you can see here. So now you can easily calculate what? Angle what? You can easily calculate angle QSR. Angle QSR is equal to what? 145 degrees minus what? 90 degrees, which is equal to what? 145 degrees minus 90 degrees will give what? 55 degrees. So meaning that the angle here is 55 degrees. Now, when you now look at this very well, this 55 degrees is equal to this angle in the same segment. For example, now if I join this chord together, this chord here, this chord QR together, with a dotted what? Dotted line, with a dashed line. So this is a chord QR. Now, and this forms a segment. So this is a segment. So this means that this area here is a segment. This is a segment. Now, and if this is a segment, this angle here will be equal to x. So x is equal to what? 55 degrees. Why? Angles in the same segment. Because they come from what? In the same what? Angle in the same segment. Angle in the same segment. It's very important to put what? Same what? Angle in the same what? Angle in the same segment are what? Are equal. Angle in the same segment are angle in the same segment are equal. So 55 degrees is equal to what? X. So that's that about question number what? 3. Now number 4 question says that in the diagram above, O is the center of the circle. In this what? Diagram now, O is the center of the circle. If angle UOT is 70 degrees and angle RST RST is 100, as you can see it. Already we calculate angle RUO. We have to calculate this angle. This angle, we have to calculate this angle. How do you calculate angle what? Angle RUO. Now to calculate angle RUO, you need what? The O angle here. You need the O angle here. To calculate angle RUO, you need the O angle here. Now you can subtract it. You subtract this angle here, this angle, small angle here, from this big angle so that I can get this one. Now, and how do you go about that? The first thing is to first get what? Angle RUT. Angle RUT. The angle RUT is this big angle. First, number 4 question. Get what? Angle RUT first. Angle RUT first. And how do you go about angle RUT? Angle RUT plus angle ST. RST. Angle RUT. We are looking for angle RUT now. Angle RUT plus angle RST is equal to 180 degrees. Why? Opposite the interior angle of a cyclic, quadrilateral, and supplementary. Opposite interior angles of cyclic or quadrilateral are supplementary. That is, they are add up to 180 degrees. So that's why RUT plus RST is equal to 180. So now, meaning that angle RUT plus 100 degrees equals 180 degrees. So angle RUT is equal to 180 degrees minus 100 degrees is equal to what? 80 degrees. So angle RUT now is 80 degrees. Angle RUT here is 80 degrees. So the whole angle here is 80 what? Degree. Now we need to calculate this angle now. You can represent this angle here x. Why am I asking that this is x? This also must be here because this is a radius. And whenever you have radius in a circle, this radius here, the form of this is a triangle, and a triangle in a circle that has radius, we call it isosceles triangle. So means that this angle here is equal to this angle here. So x plus 70 is equal to what? 180 degrees. And the sum of angles in a triangle, x plus 70 equal to 180 degrees. Sum of angles in an isosceles or in a triangle, we want to call it an isosceles. I call this one isosceles. So as you understand how we get that what? X, isosceles what? Isosceles triangle in an isosceles what? Is sum of angles in an isosceles what? Triangle. So this is 2x now equal to 180 degrees minus what? We change this one to the other side. Minus 70 degrees. So we have 2x equal to what? 110 degrees. So we divide both sides by 2. So x here is equal to what? 55 what? Degrees. So the angle here is what? If this one is equal to 55 degrees, then what is what? Angle RUO. Angle RUO will now be equal to what? 80 degrees, which is angle what? RT minus what? Minus 55 degrees, which is angle what? OUT. So minus 55 degrees. So the answer will now be what? This is the borrow one from what? This one will come there, this one will come there. So this is 25 what? The answer is 25 degrees. We have 25 degrees there. Option what? Option B. Option. So that's on question number what? Question number 4. 5 saying that PRS lies on the circle as shown in above. Why Q lie outside the what? The circle. Find PSO, angle PSO, angle PSO, angle PSO. So we are looking for the angle here. And how do you get the angle here? Now the first thing is what? You can see that we are given an extension here, which is angle what? PRO. Considering the angle PRO, now we need to get this angle because this angle here, the angle here will be the exterior angle of this triangle. The angle here will be exterior angle of this triangle. Now let's consider what? Number 5. Consider triangle what? In triangle PRO. Triangle PRO. In triangle PRO. So angle R here, angle R, let me just represent angle R plus what? 35 degree plus what? 20 degree is equal to what? 180 degree. Right? Sum of angle in triangle, sum of angles in a triangle. So when I add this one together, angle R plus what? 55 degree equals what? 180 degree. Take this one to the right side. We have angle R equals 180 degree minus 55 degree. So what do we have? So when I borrow one from this one, this should give me what? 120 what? 125 what? 125 degree. So angle what? The angle here is 125 what? Degree. In fact, this angle here is angle in a straight line. If this is if this one is 125, if this angle here is 125 degree, so this one is also what? If this one is 125, this also is 55 degree. This is 125 degree. So if angle R is equal to 125, if angle R is equal to 125, then this place will be 55 degree. Why? Angle what? Angle here is angle R, and this angle here is sum of angle on a straight line. One that is angle R that I just calculated now, plus this angle here, plus this angle, you can call this one Y, plus angle Y equals 180 degree. That is what? That is angle on a straight line. Angles on a what? On a straight line. On a straight line. On a straight line. On a straight line. So that's why I get Y equal to 180 degree minus R. And we know that our R is 125. 180 minus what? 125. That's 55 degrees. So that's how I get what? 55 degree. Now 55 degree times 2. Angle at the center is twice angle at circumference. So if this one is X, if I represent this one with my X now, so it means that X will be what? 2 times what? 55 degree. Angle at center. Angle at center is twice angle at circumference. At circumference. Angle at circumference. Angle at center is twice angle at what? Circumference. So that's why your X here is equal to what? 110. If you don't forget, you are looking for what? Angle PSO. This O is your O. Please let me don't forget this angle PSO here. This angle PSO. Angle PSO. So if this is angle PSO, now remember that this is 110 now. This is an isosceles triangle because this is radius. So this one will be what? Let's label this one B. So it is going to be equal. So this angle is going to be equal to this angle because this is an isosceles triangle. So B plus what? 110 degree equal to 180 what? Degree. So we have 2B plus 110. 2B plus 110 degree equal to 180 degree. So we have 2B equal to 180 degree minus 110 degree. So 2B is equal to what? 70 degrees. So divide both sides by 2. So B is equal to 35 degree. So final answer 35 degrees. We have the answer here. Yes. Option A. So that's that about question number 5. Let's go to question number 6. What do we have for question number 6? You can see a tangent here. The tangent at question number 6, tangent what? S here. But is it relevant to this question? Let's see. E is what? This is isosceles triangle. Whenever you see something like this, isosceles triangle, this is 40, this is also what? 40 degree. That is for sure. It's also 40 degree. Now, the diagonal PQR is a straight line. As you can see, this is a straight line. And PS is a tangent. PS is a tangent because it touches the outside of the circle. To what? To the circle QRS with what? With line PS equal to SR. Line PS equal to SR. That's why they call it, that's why they put double mark here. So making it an isosceles triangle. An isosceles triangle is a triangle whereby two sides are equal. It has two sides that are equal and has two angles that are equal. So this 40 degrees equals this 40 degrees. So we can easily calculate this angle here. We can easily calculate angle what? X. So if you can calculate angle S, then can it help us to find angle PSR? Angle P, we are asked to calculate what? Find angle PS what? Q. We are asked to calculate, find PSQ. PSQ. We are asked to calculate this angle. So meaning that if you get this whole angle here, if you get the whole angle here, you can easily subtract it from this what? Angle. Now, there's another angle here that we need to note. Please follow me carefully. This is 90 degrees. Why is 90 degrees? Because this is a semicircle. They said you can see the center of the circle. So this is straight line as you bisect the circle into two sides, equal part. So the angle in this triangle now is 90 what? 90 degrees. So this is 90. If this is 90 degrees, then we can subtract it from the whole angle here to get the angle PSQ. So now let's do it. First of all, let's get the whole angle here. Call this whole angle here Y. So 40 degrees to avoid 40 degrees plus 40 degrees. You know how we go for this is an isosceles triangle. 40 degrees plus 40 degrees plus what? Y equals to 180 degrees. Sum of angle in a triangle. Sum of triangle. Sum of angles. Sum of angles in a what? Triangle. Sum of angles in a triangle. In a triangle. Sum of angles in a triangle is equal to what? Equal to 180 degrees. So that's why we have that. So 180 degrees plus y equal to 180 degrees. So y is equal to what? 180 degrees minus 80 degrees. So y is equal to 100 what? Degree. Am I right? Yes, 100 degrees. If y is 100 degrees, then we can easily get our what? And we know that what? Angle QSR or angle QSR is 90 degrees. Well, angle QSR is equal to what? 90 degrees. Why? Angle in a semicircle is equal to 90 degrees. Angle in a semicircle is equal to 90 degrees. Angle in a semicircle. Always state your reason. Angle in a semicircle is equal to what? 90 degrees. So therefore, angle PSQ, angle PSQ is equal to what? 100 degrees minus what? 90 degrees. This is 100, which is y that we just calculate, minus what? 90 degrees, which is equal to 10 what? The final answer. So that is that about that. The last question, which is question number 7. And let's do question number 7, which is the last question. Question number 7 here, we can see, so in this diagram, what is the center of circle? Center of circle POM is a diameter. POM, yes, in diameter. So if we have diameter, this angle here is equal to 90 degrees. This here is angle equal to 90 degrees because there is a diameter here. And this angle MNQ is equal to 42 is equal to this angle. Angle is the same segment. This is a segment. This is a segment. So 42 is equal to angle MPQ. PQ is equal to what? 42 degrees. Angle is same segment. Angle is same segment. Angle same segment. Same segment. So we need that angle what? We need that angle QNP is same as angle what? NPQ. So angle MNQ is the same thing as what? Angle MPQ. So that's why we have 42 degree in both sides. This is 42 degrees. So I don't want to make any repetition. Note that this angle MNP is equal to angle MP equal to 42 degrees. Angle is same segment. Now, if that be the case, so we know this one will be 42, this one is 90 degrees. You can easily calculate angle QMP. You have to calculate this angle, which I label what? X. Calculate angle X, which is angle what? QM what? now will now be plus what? I will QMP plus what? 42 degree plus 90 degree equal to 180 degree. Sum of angles in the triangle as well. Sum of angles in the triangle. So now angle QMP. Angle QMP is what we represent with what? Angle QMP is what we represent with x. So x plus what? So plus is 132 degree equal to 180 degree. So x equal to 180 degree minus what? 132 degree. So this one is 8. Bottom one from this one is 8. So this one is 10. 8. So this one is 7. 7 minus 3. And you have 40 what? 48 degree. The answer is 48 degree. Option what? Option A. 48 degree. Option A. So that's that. We have come to the end of today's class. Please, if you have any questions, comments, remember to drop it in the comment box, and also remember to like this video and share with your friend. Don't forget to subscribe. Keep on watching Readers Academic Tutorial. See you next time, and God bless you.